Hey, astronomy students. We're going to go through the star wheel locator assignment right now. This was kind of a tricky one with grading it through the Google form, and so I'm just going to kind of go through and show you the real answers, and your answers that you put down already will not be reflective of your actual score. So take a look at this, make sure you review this so you understand how to use this locator. So you got your name. Actually, yep. So first one is circumpolar stars. There's actually six. This is the reason why some of you got this so wrong. It's actually six circumpolar stars. So check the circumpolar constellation. So when you're here on this locator, as you spin this, you got to make sure that the stars that you're spinning are always visible. However you turn this, the stars that are close to that little rivet, which is Polaris, the North Star, those are the ones that are always visible. Those are going to be your circumpolar stars. All right, so they're open all year round. And so those are Little Dipper, Big Dipper, Camelopardalis, Cephus, Draco, and Cassiopeia. Those are your six circumpolar stars. If you go to the North Pole, will there be more or fewer circumpolar constellations? So you think about it, this is set up like this to be approximately 40 degrees north latitude. So that's like Chicago, Illinois. So the farther north you get, the closer you are to the North Pole. And so we are sitting here right at 45 degrees north latitude. So we would actually see a little bit more stars up here. So you kind of cut this up a little bit more for our view at 45 degrees north. Not worth actually cutting this. If you were like sitting in Barrow, Alaska or Nome, Alaska, which is way far north, very close to the North Pole, this rivet would end up being very, very close to the center because your zenith straight up is almost at the North Pole. So you would definitely end up seeing more circumpolar constellations. All right, finding your way. So this talks about how to sort of find your way. We use this Big Dipper here because the North Star is on the last star of the Little Dipper's handle. It's very difficult to find though. And so because the Big Dipper is easy to find, we take these last two stars and kind of point them towards the Little Dipper and towards the North Star. So those are called pointer stars. So what star is the point in the sky that all stars and constellations rotate around? Kind of a tricky one. It's more than one answer. It is the North Star or Polaris. So there you go. Same star, North Star, Polaris, same thing. How often do the stars and constellations rotate around this point? So you think about it. Using this, as you turn this, when you got your times, you got midnight, and you go all the way around, and now we're back to midnight. How many times did that rotate around? That was once a day. So once a day, stars rotate around that fixed point. If the previous answer is true, what motion is responsible for constellations moving, rising, and setting? So what causes Earth to do this? What causes the stars to sort of spin in the sky? Is the Earth's rotation. So as the Earth spins, since we are sitting here stuck on Earth, you're looking up, you actually spin with Earth, but it appears that the stars spin. So the Earth's rotation, that is what's causing it. This question is a good example of why it's difficult to grade using Google Forms. Explain in your own words how to find the North Star using the Big Dipper. So basically, you take the last two stars in the Big Dipper and follow them up, and you can see the North Star. It's right there. And it's difficult to see, but once you find these two, the North Star is kind of easy to find, but the Little Dipper in general is difficult. So again, there's the Big Dipper, and even on here, there's a little arrow right by my finger that says pointer. and it points towards that brass rivet, which is the North Star. So somehow you're going to put that into here. All right, so the next section is using the star wheel, and there's all these little things to do with your actual star wheel. So which direction is the North Star closest to? That would be the north. What is the line running like a circle through the middle of the wheel? It's actually right here. You can see it. There's this curved line. It's kind of backwards in the camera, but there's that curved line there. And that curved line is called the ecliptic. All the constellations are on that line. And so, or excuse me, not all the constellations are on the line. All the horoscope constellations are on the line. So Taurus and Leo and Sagittarius and Capricorn, those are all on that ecliptic line. And depending on where they are at zenith during what time of the year, that's your horoscope. So we'll talk about that a little later. So there's another imaginary line running north and south directly over your head. This is the meridian. On the meridian, in the center of the window, is a point called the zenith. All right, so basically, right smack dab in the middle of this oval, that is your zenith, and that's looking straight up above you. All right, so you're going to move your star wheel to January 5th, 9 p.m. What constellation is at your zenith? So you make sure it is January 5th. There we go. January 5th, 9 p.m. And right smack dab in the middle is Perseus. And so this is where a lot of people got this wrong, because if you misspelled Perseus, you'd get it wrong. And if you were off a little bit, you might think it's Auriga, but the best answer for January 5th is Perseus. So you could say Perseus. So then September 5th, 9 p.m. So you're going to shift this over to September 5th, 9 p.m. right there. And you're going to figure out that is Cygnus. Well, you know what? I screwed this up. This one is Perseus. This one is straight up. That's where you want to look. Look for your zenith straight above you. This one is Cygnus. Cygnus the Swan is at your zenith then. April 30th, 2 a.m. What's your zenith? So you go to April 30th, 2 a.m. right there. And then again, zenith means right smack dab in the middle, and it is Hercules. Did that again. January 15th, 10 p.m. Which constellation? Now, make sure you're reading your test questions carefully. Which constellation is at the meridian equator intersection? So remember, the meridian is straight up and down. That's the meridian right here. And that curved line, the curved line on the blue is your equator. And so January 15th, 10 p.m. is right there. And right where they meet is Orion. Orion is one of the easiest constellations to see. Two bright stars in the constellation. So if you look carefully at Orion, there are two stars that are named. One is Rigel and one is Betelgeuse. Betelgeuse and Rigel. All right. At what time on December 20th would you see Orion rising? So now you got to take Orion and you have to move it back until Orion is in the east, because stars and planets rise in the east and set in the west. And so you have to bring it all the way back to the east. And so right about here, when Orion is gone, and as time goes by, Orion will start to appear right there. Now you got to figure out what time it is. So on December 20th, It is about 6 p.m. So you could say 6 p.m. And think about that. When you're answering these questions, just think about it. Does 6 p.m. make sense? Would a constellation start rising at 6 p.m.? If it's the stars, that sounds about right. December 20th, 6 p.m., it'd be dark, and so you'd start to see those stars come up. July 15th, 10 a.m., where would Orion be in your sky? So you just keep turning it. 10 a.m., July 15th. That's right there. Now, Orion is right there. Do we see Orion? Yes. So Orion would be in the center of the sky. What's wrong with seeing it at that time? You gotta use your brain. 10 a.m. Do you see stars at 10 a.m.? Not usually. The sun blocks out starlight. There you go. And then the last question, I'm hoping you're going to go with a 4 or a 5 here. All right. I'm hoping you're going to go with a 4 or 5. I'm going to go with a 5. Make sure you put which one you have. All right. So that is what we have for this little video. If you have questions, as always, please let me know.